Let us talk about concepts of deadlock. First of all, we will understand what is deadlock. A deadlock is a situation where a set of processes is blocked because each process is holding a resource and waiting for another resource acquired by some other process. Consider a simple situation when two trains are coming towards each other on the same track and there is only one track. None of the trains can move once they are in front of each other. Similarly, the system has two tape drives, process P0 and process P1. Each hold one tape drive and each needs another one. A deadlock situation can arise if the following four necessary conditions hold simultaneously. First, mutual exclusion. Only one process can use a resource at any given time, such that the resources are non shareable. Second, hold and wait. A process is holding at least one resource at a time and is waiting to acquire other resources held by some other processes. Third, no prevention. A resource cannot be taken from a process unless the process releases the resource. And the last one, circular wait. Set of processes are waiting for each other in a circular fashion. It is important to handle deadlock. There are some methods of handling deadlocks. First, deadlock prevention. Second, deadlock avoidance. And the last, deadlock detection and recovery. Now, let us understand these handling methods of deadlock one by one. First of all, we understand deadlock prevention. Deadlock prevention provides a set of methods to ensure that at least one of the necessary conditions cannot hold. These methods prevent deadlocks by constraining how requests for resources can be made. How we can avoid or prevent four necessary conditions. First, mutual exclusion. Some resources like printers require exclusive access. However, preventing mutual exclusion completely might not be feasible, especially for these resources. Second, hold and wait. These conditions can be prevented by requiring processes to request all their necessary resources at once and blocking them until all requests can be granted simultaneously. These can lead to inefficiency if processes do not know their resources needs in advance. Third, no prevention. To prevent this, a resource held by a process should not be forcibly taken away, even if another process is waiting for it. These can be addressed by ensuring that processes release resources when they no longer need. And the last, circular wait. This is the most common cause of deadlocks. To prevent it, a specific ordering of resource request can be imposed. For example, a process can be required to request resources in a predetermined sequence. Second, we will discuss deadlock avoidance. The deadlock avoidance method is used by the operating system in order to check whether the system is in a safe state or in an unsafe state. And in order to avoid the deadlocks, the process must need to tell the operating system about the maximum number of resources a process can request in order to complete its execution. We use Banker's algorithm, resource allocation graph algorithm, to avoid deadlock. And the last deadlock handling method is deadlock detection and recovery. We let the system fall into a deadlock, and if it happens, we detect it using a detection algorithm and try to recover. Some ways of recovery are as follow: aborting all the deadlock process, abort one process at a time until the system recovers from the deadlock. And the last, resource preemption. Resources are taken one by one from a process and assigned to higher priority processes until the deadlock is resolved. That's all for today's video. Thank you.